Imagine a place 13,000 feet beneath the waves, crushed by darkness where oxygen, the very thing we breathe, is being made. No sunlight, no plants, yet somehow oxygen is there. This isn't some sci-fi movie. It's a newly uncovered secret of our own planet, a process that could literally rewrite the story of life. But here's the catch. This miracle might be on borrowed time. Section 1. The abyss awakens a shocking discovery. The deep ocean, a world of endless night, crushing pressure, and near-freezing temperatures, has always kept its secrets close. But recently, out in a huge abyssal plain called the Clarion-Clipperton Zone, between Hawaii and Mexico, scientists stumbled onto something that blew all their expectations out of the water. Down around 4,000 meters, or nearly 13,000 feet, where sunlight is just a distant memory, their sensors started picking up the impossible: oxygen. Now, for decades, we thought we had it figured out. Oxygen mostly comes from photosynthesis, plants and algae using sunlight. But deep sea? That was supposed to be where oxygen gets used up, not made. So when the first readings in 2013 hinted at extra oxygen down there, researchers naturally thought, faulty sensors. But the strange readings kept showing up in later studies. The evidence piled up, pointing to something brand new: dark oxygen made without any sunlight at all. This wasn't just a little blip. It sent shockwaves through the scientific world, making us rethink some of the most basic ideas about how our planet works. Section 2. The geobatteries: how dark oxygen is made. So where's this mysterious dark oxygen coming from? Well, the source seems to be just as fascinating as the oxygen itself, things called polymetallic nodules. Picture potato-sized, lumpy rocks, trillions of them, scattered across these deep-sea plains, especially in that Clarion-Clipperton zone. For millions of years, they've been slowly growing, layer by layer, collecting rich deposits of valuable metals like manganese, nickel, copper, and cobalt, all key stuff for green tech like electric car batteries and smartphones. The main idea for how these nodules make oxygen is a process called electrolysis. Basically, the nodules are like natural, super slow-forming batteries, or geobatteries. The different metal layers inside them, built up over ages, create slightly different electrical charges, and that generates an electrical current. This current is thought to be strong enough to split the seawater around them into hydrogen and oxygen. Researchers actually measured voltages up to 0.95 volts on some nodules. To put that in perspective, you only need about 1.5 volts, like a regular battery, to split seawater, and sometimes even less if certain metals are around to help. This quiet chemical reaction, happening in the pitch-black deep, is what scientists think is making this dark oxygen. It's geology acting like biology, a natural battery fueling a life-giving process in one of Earth's toughest spots. The scientists who first saw it, they genuinely thought their equipment was broken. Section 3. Rewriting life's story: the profound implications. The fact that dark oxygen exists isn't just a cool science fact. It could totally change how we think about life's beginnings on Earth, and maybe even on other planets. For ages, the main theory was that Earth got its oxygen-rich atmosphere. And so, us oxygen-breathing creatures, thanks to tiny photosynthetic organisms like cyanobacteria that need sunlight. Dark oxygen suggests there might have been another way, maybe even an earlier one. Could there have been pockets of oxygen in the deep sea supporting early life even before photosynthesis really took off? Professor Andrew Sweetman, a key researcher here, put it like this: for aerobic life to begin on the planet, there had to be oxygen. We now know that there is oxygen produced in the deep sea where there is no light. I think we therefore need to revisit questions like, where could aerobic life have begun? And it doesn't stop with Earth. This discovery makes you wonder about life on other worlds. Moons like Jupiter's Europa or Saturn's Enceladus are thought to have huge oceans under icy shells. If dark oxygen can be made by rocks and water here, maybe similar things are happening in those dark, alien oceans, creating spots where extraterrestrial life could exist. Back on Earth, what this dark oxygen means for our own deep seas is another huge question. It might be a vital, hidden source of oxygen for the strange and little understood ecosystems that cluster around these nodules, full of creatures built for extreme pressure and no light. The implications, as Nick Owens from the Scottish Association for Marine Science said, are utterly profound. Section 4. The collision course, mining the cradle of dark oxygen. Here's the kicker: the very polymetallic nodules making this game-changing dark oxygen are also square in the sights of an impending, Industrial gold rush deep-sea mining. These aren't just geological oddities. They're jam-packed with high-grade nickel, cobalt, copper, and manganese. These are metals considered vital for shifting to a green economy. Demand for them is skyrocketing thanks to electric vehicles, wind turbines, solar panels, and all that jazz. Countries and private companies are seriously eyeing the Clarion-Clipperton Zone, the same place dark oxygen was found, as prime mining territory. This massive undersea plain, thought to hold trillions of these metallic potatoes, is fast becoming ground zero for a high-stakes showdown. Companies like the Metals Company are already exploring there and have said they plan to apply for mining licenses, possibly as soon as 2025. Pro-mining folks argue that these deep-sea metals could mean less reliance on land-based mines, which often come with big environmental problems and political headaches. But this puts our just emerging understanding of dark oxygen and the unique life it supports on a direct collision course with the massive economic and political push to dig up these deep-sea treasures. The race is on, but what's the cost to this newfound mysterious life support system? Section 5. The scientific debate and the unseen battlefield. The discovery of dark oxygen, though a big deal, hasn't convinced everyone and has sparked a pretty intense debate among scientists. Some researchers, and interestingly, deep-sea mining companies like the Metals Company are questioning the findings. Skeptics think the oxygen readings might just be experimental hiccups like trapped air bubbles or electrical leaks from equipment, not some new natural process. Several papers trying to debunk the dark oxygen idea have even been submitted, claiming the whole hypothesis can be wholly rejected because of possible mistakes in how the research was done. But the dark oxygen proponents, like lead researcher Andrew Sweetman, say they tried hard to poke holes in their own data before publishing and are planning more trips to get more evidence and answer the critics. One preliminary study from March 2025 even hints at another possibility. Maybe certain deep-sea bacteria can produce dark oxygen by breaking down nitrates. This scientific back and forth is vital, but it's all happening while the clock is ticking. While scientists argue the real battlefield is mostly hidden thousands of feet down. The International Seabed Authority, that's the UN-linked group in charge of mining in international waters, is right in the middle of hashing out the mining code, the rulebook for deep-sea exploitation. These talks are super complicated and member countries are seriously divided. A growing group of over 30 nations, France included, is calling for a timeout, a precautionary pause on deep-sea mining. They say we just don't know enough about these deep-sea ecosystems, what lives there, and how they'd handle being disturbed to go ahead responsibly. The dark oxygen discovery just adds another huge question mark and shows what we could lose before we even really get it. Scooping up these nodules, which are basically the top layer of the seafloor in many areas, could wipe out these unique habitats, possibly killing off species and messing up basic natural processes like dark oxygen production. Section 6. A geopolitical tinderbox, the global war for resources. Now, when the title says global war, it's not necessarily talking about old-school fleets and armies. It's about the fierce geopolitical jockeying and potential for real conflict over these deep-sea resources. Getting hands on critical minerals is a massive strategic deal for major world powers. Countries like China, Russia, and India are pouring money into exploration tech, seeing the deep sea as a new frontier for their own tech independence and economic clout. The United States is also keen to secure these materials, partly to cut its reliance on other nations for stuff that is essential for the green transition and national security. This whole race is creating new international tensions. The International Seabed Authority itself is where a lot of these tensions play out. It has a tough job: protect the ocean and regulate mining while making sure any benefits are shared fairly. Some small island nations like Nauru have backed mining companies, hoping for an economic boost. They've even used treaty rules that could force the ESA to look at mining applications before all the regulations are even finished, cranking up the pressure massively. This has sparked worries that commercial mining could kick off as early as 2025, whether the science is settled or strong environmental rules are in place or not. This push to exploit these resources before we really get what they mean ecologically, including the role of dark oxygen, is setting the stage for potential fights and a new scramble for resources in what is pretty much the planet's last untouched wilderness. The decisions made in the next few years could lock us onto a path of consequences we can't undo, not just for the deep ocean, but for global stability too. This incredible discovery of dark oxygen, right on the cusp of potential large-scale deep-sea mining, gives us a critical choice. Do we rush in to grab these resources for quick profit, possibly wrecking wonders we're only just starting to understand? Or do we hit pause, focus on understanding, and protect these unique, life-giving spots in the deep? What do you think about this high-stakes clash between discovery and demand? Should we be mining the deep sea? Tell us your thoughts in the comments below. And if you want to keep up with the crucial stories shaping our planet's future, make sure to subscribe and ring that notification bell. Conclusion: in the deep parts of our oceans, once thought to be just silent, dark emptiness, are turning out to be way more dynamic and mysterious than we ever dreamed. The idea that dark oxygen is being made by these polymetallic nodules is a stunning example of nature's cleverness, a process that can make us rewrite the book on how life started and even hint at possibilities for life beyond Earth. Yet, this natural marvel is now at the heart of a brewing conflict. The huge pressure to mine these very same nodules for their valuable metals is a direct threat to these fresh discoveries and the delicate ecosystems they support. The scientific jury is still out on dark oxygen, with fair questions being asked and a desperate need for more research. But the political and economic train for deep-sea mining is picking up speed, threatening to leave our understanding in the dust. We're standing on a bit of a cliff edge. On one side, the chance for amazing scientific insight and saving unique forms of life. On the other, the temptation of resource wealth that could do permanent harm to an environment we barely know and maybe even stir up new global tensions. Will we choose to plunder the darkness for its minerals, or will we protect the light of discovery, no matter how faint and mysterious it seems right now? The fate of dark oxygen and the deep-sea worlds that create it is truly hanging in the balance.